We are going to start off by drawing a picture. In this picture we have a fence with 3 sides that borders a straight river, so no fencing is needed alongside the river. Next, we are going to assign symbols to the unknown quantities. The 2 shorter sides will be labeled y, and the side parallel to the river will be labeled x. We will now create the primary equation to be maximized in terms of the unknown quantities. In this problem, the primary equation will be area equals the product of x and y. Next, the secondary equation will allow us to reduce the primary equation to having a single independent variable so that we can find x. We will use the equation p equals the sum of x and 2y. Next, we are going to use the secondary equation to solve for the x in the primary equation. Since the farmer has a total of 2,400 feet of fencing, we are going to plug that in for p. Then we can isolate x. We are going to plug this value of x into our primary equation in order to solve for y. Next, we distribute. Then we take the derivative of this and we can use the chain rule. We're going to set the derivative to 0 so we can move 4y over and solve for y. We're going to divide each side by 4. And we find that y equals 600. We are going to go back to the secondary equation and plug in y to get the value of x. We get that x equals 1200. Now that we have our x and y values, we are going to determine if this is a minimum or a maximum by plugging in values greater than 600 and less than 600 into the number line. Here I used 599 and 601. We get a positive answer for numbers less than 600, and we get a negative answer for numbers more than 600. Since we go from increasing to decreasing, we have a max. Therefore, the dimensions to maximize the area are 600 by 1200 feet.